Hey everybody, in this video we're going to be working through some reflection questions regarding some plane mirrors. Looking at our first one, you would like to view yourself in a mirror. What is the minimum height of the mirror? Well, when we think about this, our rules of reflection is that when we have a plane mirror, the angle of incidence is equal to the angle of reflection. So thinking about this logically, it would be that our height of our person, well, to see our feet, we would need a mirror at least half that length. However, we can talk it through and explain it that way. However, we also need to prove it mathematically. So in these situations, the first step we're going to be doing is drawing a diagram. First, I'm going to draw a person in front of a mirror. I'm going to say that my person is of height h. They're going to be a distance d away from the mirror. The mirror is going to be of length L. And that remaining height is going to be h minus L. Now I need the person to see his feet, so I'm going to draw in those rays. And the last thing I need to do is draw in the normal to the mirror, so that I can define the two angles of incidence and reflection. What I have out of this is actually two triangles. My first triangle is this area here, where I'm getting my angle of incidence is going to be a relationship between the tangent of d and h minus L. And my other triangle, which is going to be my length L in relation to d and the angle of reflection. Well, what do we get from this? From our two triangles, we can get our tangent relationship, where the tangent of the angle of incidence is equal to the height minus the length divided by the distance away. And our other triangle gives us that the tan of the angle of reflection is equal to the length divided by the distance. However, we also know that the angle of incidence is equal to the angle of reflection. This means that tan of the angle of incidence and tan of the angle of reflection are going to be equal to the same thing. That means the height minus the length divided by the distance is going to be equal to the length divided by the distance. Timesing both sides through by d gives us the height minus the length is equal to the length, which gives us height is equal to 2L. That gives us that our length is equal to height divided by 2. Moving on to the next question, we're going to be finding out what the angle theta is. To start off each of these diagrams, I'm going to be drawing the normal where the rays interact with the mirror. We know that the normal makes a 90-degree angle to the mirror. So therefore that each one of these components up to the orange line must be equal to 90. Therefore 90 minus 50 gives us a degree of 40. We know that the angle of incidence is equal to the angle of reflection, so the other side must also be 40. Then this means that we can also fill out the other side, which is going to give us 50 degrees. Now this triangle here in the corner is a right angle triangle. This means that our other side must be 40 degrees. This means that the other side of this angle must be 50 in here, which gives us 50 in here, and this means that our angle theta is going to be equal to 40 degrees. In our next diagram, we have a tilt on one of our mirrors. We can go through the same process as the first one and fill out the first part of our mirror. So we get 40 degrees, and 50 degrees. However, now we don't have a right angle triangle. This angle in here, though, is going to be 90 minus 10 because of our 10-degree slope in, which gives us an angle of 80 degrees in here. That means that our final angle to make a triangle with 180 degrees must be 50 degrees. Then we also have a 40 degree to make up 90, another 40 degrees because of our laws of reflection. That means our theta here is at 50 degrees. Now we have the mirror bent in the opposite direction. Now let's go and find what the angle of theta is. Again, we can fill out our first ray section. So we're going to have 60 degrees in here and 30 degrees on the outside. Now, because the mirror is bent out, this angle in here is going to be 90 plus our 10 degrees. So it's going to be equal to 100 degrees. That means that the angle on the other side of the triangle is going to be 50 degrees, which gives us 40 degrees on the inside to make up 90, 40 degrees again. And that means that on our opposite side here is going to be 50 degrees. So that gives us our theta is equal to 50 degrees. In summary, we've looked at a couple of plane mirror questions. Thanks for watching. See you in the next video.